We're trying to go back to a point in time that's about, say, 35 million years ago, roughly, when Antarctica went through a dramatic change from going from a very warm or greenhouse, we call it, type climate to the more colder icehouse environment that we have today. Ideally, we'd like to go out and find a drill site where we can drill to recover sediments of that age so we could study them more closely to understand how Antarctica responded to that warmer temperature and maybe understand a little bit better about how it responded when it turned cold. What we're going to do on this project is try to image the sediments that are down below the ocean to get a picture about what they look like, to try to have an idea about where the best sediments are to drill. The way that we're going to do that is we're going to use seismic techniques where we put sound energy into the water column using an air gun. Those reflections build us an image of what the sediments are like, much in the same way that we would use ultrasound to image what's inside of a person. We're just doing it on a much larger scale.
Hey, how you doing for Ed, Sam?
Hanging in there. Go ahead.
One of my graduate students will process these data, and then we'll tie that into some of the seismic data that's nearby, and we'll start to make some sense about what those sedimentary layers are in the subsurface. And hopefully we'll find sediments that we suspect are of the right age that we would want to drill in a few years.
We pulled together some seismic data. We can see a few things. It's pretty obvious to see the seafloor bottom. And we can also see a pretty major unconformity. We're only seeing 1/60th of the data here. Once we put everything together and start processing things, we can get a much clearer picture than what we have here. Kind of the fruit of our labor here on the screen.
This area here is unique in that it has captured sediments from this greenhouse world. And so this is really important because when it comes to understanding the climate history of Earth, Antarctica is one of the last pieces of the climate puzzle yet to be put into place. We have records, thousands of records from all around the world, except in Antarctica.
We're going to a very harsh environment where seismic data, people have had problems collecting in the past. The sea ice environment in particular is problematic. And we seem to have resolved that problem and are collecting good seismic data in a sea ice environment. You know, and I take pleasure in that success.
Okay.
One of the philosophies guiding us is, let's go back in time to look at a period in time when Antarctica was much warmer, so that we might use that as an analog to understand what might happen 100 years from now when the planet gets much warmer. And by much warmer, we're really talking about a few degrees, and that few degrees of warming could bring about fairly dramatic change in the climate of not just Antarctica, but the rest of the world.